let us look at the topic multiple integration. Now, you remember that integration is a process of adding up items, where the smaller the item gets smaller, so you need more of them. The dimensions get smaller, so you need more of them. And then, as the dimension approach 0, the number of them that you need in approach infinity. You remember that, alright? And you remember using integration to calculate area. Now, when you talk about multiple integration, what you're talking about is double integration and triple integration. But what we're going to be looking at right now is double integration, right? You remember that when you found the area of an object or of a surface using integration, you did just one integration. But the fact is, it is double integration that is used to find area. It seems as if you did single integration because you really bypassed the first part of double integration. But we'll soon look at that. And triple integration is used to find volume. Alright? Now, suppose we have this large rectangle here. And let us say the height is y and the width is x. We know that the area of a rectangle is height times width. We know that already, right? But this rectangle, it can be built up from some small squares with width delta x, changing x, right? Use delta because we're going to make it change. And the height is delta y. Now, if we should find the area of this element here, we'd multiply delta y by delta x, alright? Now, let us say we are building this large rectangle and we put these small squares in it, and we're piling up the squares from the floor up to the ceiling of the rectangle. Let's make the rectangle a little higher so that we can stack one more square. Good. Now what we're doing is we're summing up from, let's say the bottom is y1 and the top is y2. We're summing up from y is equal to y1 to the top, y is equal to y2, whatever that is. Now, we are adding the delta y's as we stack them up. We're adding this one, this delta y plus this delta y plus this delta y plus this delta y. You see that? The height of each square. And then, the fact is that in order to fill out the entire rectangle that we have, we're going to have more of this and stacking them sideways. We're kind of running out of squares. Let me make copies of these squares here to get more of them. Alright, so we stacked 4 of them from floor to ceiling. Now let's make another shape like that where we're going to stack these from floor to ceiling. Then we combine them into one object. Alright, good. So we have one here. We have another one here. That's 2, 3, 1, 2, 3, 4. Alright. And then we could have one here and make another column from floor to ceiling here. So now we would have found the entire area of the rectangle. Now the width going across, we're adding this delta x, this one, delta x plus 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 delta x. So we're adding up. Alright, so this is the height and the width. We're adding from x is equal to, let's call on the left x1 and the right x equal to x2, whatever it is. So we have x1 here and x2 here. And what we added a while ago is delta x. Now the thing is, we're stacking up, we're adding up from y1 to y2 of delta y, that's the height, and from x1 to x2 of delta x, that's the width. Now the total area of the rectangle is going to be the sum from y equal y1 to y equals y2 of delta y multiplied by the sum from x equals x1 to x equals x2 of delta x. Now, a popular way to write all of this is to say we're finding the sum of y equals y1 to y equals y2, and when we have that, we have the column going from floor to ceiling, and then we stack these up left to right. So we're summing that. Well, this was delta y. Then we're summing from x equals x1 to x equals x2. We're packing them from left to right. And what we're packing from left to right? The width delta x. Alright? So now, you remember that as these rectangles these squares get smaller and smaller, we need more of them to cover the entire rectangle. Now, if the width delta x gets so small that it's approaching 0, and delta y, the height, also gets so small that it's approaching 0, then we change the sigma notation sign to integral. So we're finding the integral from y equals y1 to y equals y2 of delta y, and integral from x is equal to x1 to x is equal to x2 of delta x. Alright? Well, there's a 1 here. You don't see it there, but there's a 1 there. Alright, so that is that. That will give us the area of the rectangle. I'm going to look at an example using the same rectangle, using numbers, in our next video.